Alright, so in this video we're going to be using matrix algebra to calculate the revenue of a small family-owned movie theater. Suppose we are the chief financial officer and there's a premiere, a new movie's coming out. Not exactly new, it's Emoji Movie 6. And somehow, after 5 parts of terrible jokes and non-existent plot, kids love it, they still want more, parents hate it, there's nothing they can do, they still gotta pay, take their kids to the theater. And well, we don't care, it's good news for us, it's a cash cow, and we're gonna milk it. So, our movie theater offers 3 different tiers of tickets. The yellow tier, priced at $10, and the red tier priced at $15, and lastly the purple royalty tier at a whopping $20. And we have 3 screening times. The first one is 7 p.m., the second one is 3 p.m., and believe it or not, there's an 8 a.m. screening. So what would be the most efficient way to arrange those screenings? And perhaps you could replace one of the screenings with a different movie. That's something we got to find out, and for that we're going to try and find out the total revenue of every screening time. Now, if we are given the sales for every tier for a particular screening, and we have 3 screenings with their respective ticket sales, how could we set up a matrix or matrices to calculate the total revenue in one simple operation? I'll give you time to think about it. Pause the video, take your time, and I'll show you in a second. All right, ready? So this is what it's going to look like. Now, we have our first matrix with the screening times. So the first row is the 7 p.m., for example. The second row is 3 p.m., and the third row is 8 a.m. And we have our tiers as columns. So the first column is the $10 tickets, the second column is the $15 tickets, and the third column is the $20 tickets. Now, when we multiply this left-hand side matrix by our vector matrix with the prices, we get the total revenue for every screening time. So for 7 p.m., we're going to get 40 plus 90 and plus 160. And that gives us $290 in revenue. For the 3 p.m. screening, we have 30 plus 75 and plus 160. And that gives us $265 in revenue. And lastly, we have 20 plus 45 and plus 120, or a total of $185 for the 8 a.m. screening. Now, obviously, the results are pretty predictable. You have the most popular time of 7 p.m. and the least popular time of 8 a.m. because nobody wants to go see Emoji Movie 6, and even less so when it's 8 in the morning. And that gives us our revenue. And if we want to, we can add them together and get the total revenue for all screenings. Now, this problem is solved, and how about I'll give you one to try and solve on your own. Nothing complicated or fancy, you're given all of the data, and all you have to do is set up a matrix operation to find the total number of defective units each month. In this video, we're going to again assume the role of a chief financial officer. However, this time we are trying to forecast the profits of a factory. And we have in a table the expected number of units that will be produced in the summer of the coming year. And we have our values for factory 1, 2, and 3 for the month of June, July, and August respectively. Now, we know from experience and from our statisticians that the defect rates are slightly different for each factory, and we know that the defect rate is 3% for factory 1, 2% for factory 2, and 5% for factory 3. So, given all of this information, let's try and forecast the number of defective units for each month so that we can subtract this number from the total number of units, and in the next step, which we're not going to cover, it's outside of the scope of this video, but we could then calculate the actual revenue for all of the units sold minus the defective units. Now, how do we set up multiplication so that we get as our result a vector matrix that gives us the total number of defective units for each month? Again, I'll give you a second to contemplate and I'll move on to the solution. So pause the video right now if you want to solve this on your own. All right, so let's go ahead and see what we can do. So first of all, we need to get the transpose of our left-hand side matrix with the month and the factories. And now we have as our rows the month of June, July, and August. And as our columns, we have factory 1, factory 2, and factory 3. And we multiply that by our defect rates, and we have respectively for each factory the defect rates of 0.03, 0.02, and 0.05. Now let's multiply that and find the total number of defective units for each month. For June, we have 90 plus 30 plus 160. That gives us a total of 280 defective units. For the month of July, we have 120 plus 36 and plus 175, or a total of 331 unit that is defective. Lastly, for August, we have 75 plus 70 and plus 145. That gives us 290 defective units. So just like that, we obtain our vector matrix, and we now know that July will have the highest amount of defective units. However, that doesn't really tell us anything except that there will be more units produced in July. But now if we know the total number of units and the number of defective units, we may calculate how many units will actually be sold in the end and what our revenue is going to look like. Want to learn more? Check out our other math videos and subscribe for new ones.